linear transformation and matrix representation of a cross-product tensor. In this video, we will solve the following example. A tensor T maps each vector A to another vector given by transformation of vector A is equal to M cross A. M is a specified vector. Prove that T is a linear transformation. Given M is equal to E1 plus E2. Determine the matrix representation of tensor T. E1 and E2 are two coordinate bases. As explained in the video shown at the top right, to prove the linearity of the transformation T, it is sufficient to show the following equality. Let's start with the left-hand side of equation 3. Transformation of alpha A plus beta B is equal to M cross alpha A plus beta B using equation 1. It is equal to M cross alpha A plus M cross beta B. Using the distributive property of the cross product, the scalars alpha and beta can be factored out. Using the equation 1, it is equal to alpha transformation of A plus beta transformation of B, which is the right-hand side of equation 3. Therefore, equation 3 is satisfied, and the transformation T defined as transformation of A equals M cross A is a linear transformation or a tensor. Part B. Matrix representation of the cross-product tensor. As explained in the video shown at the top right, to calculate the components of a tensor, it is sufficient to apply the tensor to the coordinate bases. Transformation of E1 is equal to M cross E1. From the definition of vector M, it is equal to E1 plus E2 cross E1. Using the distributive property, we will have E1 cross E1 plus E2 cross E1. E1 cross E1 is equal to 0 and E2 cross E1 equals negative E3. With the same manner, the transformation of E2 is equal to E3. And the transformation of E3 is equal to E1 minus E2. In summary, we can write them as observe the way the components are placed in the matrix T.